What is up, YouTube? My name is Tav, and today we are diving deep into agentic patterns. This is the first video in a 5-part series where I'll walk you through 5 common agent patterns that are used to power AI apps. The series is based on a paper called Building Effective Agents, which Anthropic released at the end of last year. If you're building with AI, this is going to give you a solid mental model for how to structure your agents properly. Now, in each video, I'll give you a simple visual to explain the pattern. We'll break down what it does, when to use it, and then I'll show you how to implement it using TypeScript and Vercel's AI SDK. So without wasting any time, let's get into it. Now, before we jump in, there are 2 terms you really need to understand: AI agents and agentic workflows. You'll hear this thrown around a lot, sometimes even interchangeably, but they actually mean 2 different things. So let's break them down properly. First, let's talk about the autonomy. AI agents are autonomous. That means that you can give them a goal and they figure out what to do and in what order. They decide which tools to use and which actions to take. They are dynamic and flexible. Agentic workflows, on the other hand, are deterministic. You define the steps, you control the flow, the system follows a set of predictable, predefined stages, and nothing is left to chance unless you explicitly allow it. Second, let's talk about the human involvement. AI agents are typically human out of the loop. Once they start running, they don't wait for an input, they act on their own to achieve the goal you gave them. With agentic workflows, it's usually human in the loop. That means you or the system often performs manual or automated checks between the steps. You might review an output, approve something, or validate it before continuing the process. Third, let's talk about how they process information. AI agents are self-reflective and iterative. They go through a loop of planning, acting, and then they reflect on the results, adjusting the plan as they go. They are designed to learn and adapt during the execution. Agentic workflows, though, are usually more straightforward. You'll have one or few LLM calls placed at specific points. They don't reflect or replan unless you explicitly build that behavior in. So now that we've got that clear, autonomy, human involvement, and reflection, you'll be able to recognize what's going on when you see either of these in action. Now let's take a look at a specific agentic workflow pattern: prompt chaining. Here's how it works. A user sends a request. It goes into the first LLM call. The output is checked at something called a gate. Now, a gate is just a checkpoint, a place where you, the developer, can decide if the output passes or fails. For example, maybe the LLM output contains something it shouldn't, and in that case, you can exit the flow right there. But if the output looks good, you move on to the next LLM call, and then another and another, depending on your workflow. It keeps going through the chain until it hits a final output. Now, this is a very basic version. You can stack as many calls and gates as you want depending on the complexity of the task. So, the question is, when should you actually use this? Prompt chaining is great for structured tasks, stuff that can be broken down into clear, repeatable steps. It's ideal for multi-stage workflows like summarizing a long document, then checking it, then transforming it into something else. It's also a good fit when accuracy matters more than speed. So if you want things done right, even if it's a bit slower, prompt chaining has your back. Alright, now that we've covered the theory and walked through the flow, let's take a look at how we implement this using Vercel's AI SDK and TypeScript. Now let me walk you through what's happening in this code, and as we go, I'll show you how it directly maps to the prompt chaining diagram workflow from the previous section. We start by importing what we need from Vercel's AI SDK. That's OpenAI, generate text, and generate object function. We will also be using Zod for schema validation. We're using GPT-4o as our model here, but honestly, you can swap it with whatever model fits your need. Just update the imports and you're good. Then we define the async function called summarize and tag, and it takes one argument, the input. This is basically the user's request, which in our case would be some long text or an article we want to summarize. This maps to the user request in the workflow diagram. Step 1 is where we call generate text to summarize that input. This is the first LLM call in the flow. So what's actually happening? We're giving it a prompt that says, summarize this text clearly in under 100 words. Generate text takes 2 things, the model and the prompt. And what it gives us back is an object that contains the text. That text is our summary, and it will become the base for everything else downstream. Step 2 is our gate. This is where we check if the summary is actually useful. We use generate object here, which is great because it lets us define a schema using Zod. That schema says, hey, give me back a word count and a clarity score from 1 to 10. Now, why do we do this? Because generate object ensures that LLM's output is structured. We want that schema to make evaluation predictable. This maps to the gate in the workflow. Step 3 is our check. If the summary is over 100 words or has low clarity, we regenerate it. So in that case, we send it back to the LLM and say, make it shorter and clearer. That's our little quality control loop, straight from the diagram's decision path. Step 4 is our second LLM call. This time we prompt it to generate 3 to 5 topic tags for the final summary. In the workflow diagram, this is LLM call 2. And finally, we return the output, the polished summary, and the tag. That's the last part of the diagram, the final output. So yeah, every part of this code directly ties into that step of the diagram. And that's it, a simple example of prompt chaining in action. And you can already see how useful this pattern can be. So that's it for this video. I hope you found it helpful. If you like this, consider subscribing, liking the video, and sharing it with someone who might find it useful. Thanks for watching the video, and I will catch you in the next one.